We are doing one question from the chapter circle. Now let's see class 10th. In this figure, from an external point P, two tangents that is TP or PT and PS are drawn. Well, what I suggest to all my students that whenever you are doing any question of geometry, don't read the whole information. Often whatever the information you can get from the first few lines. Like we can say that from here, we are given two tangents and we know that tangent from same exterior points are equal. So first you write down, remember this property and write down somewhere that is PT is equal to PS. This will bring more clarity about the question. Now, as I read further, it says of a circle with radius r. So write down in the figure that the radius here is given as r. If OP, that is the length of OP is this, and this is the length of OP, and this is given 2 times R, right? So this length OP is, 2 times R. So I'll write 2R here, this whole length, right? And as I read it further, we need to show that the angle, that is this angle, if you can see from the figure, this angle, right? As well as this angle. These two angles is 30 degree. That's what we need to find or show that. Now, mostly I've seen that questions from the chapter circles, when it involves concepts of some other chapters, students struggle to do it. So this is what you should keep in mind, that if a question of geometry cannot be solved using the properties specifically to that chapter or other properties, do look for the properties of or the concepts you are taught in trigonometry, right? So as you can see, and particularly whenever there is a relation between side and angle. So what you can observe that in this triangle, this is a right angle triangle. Now, why did I say it's a right angle triangle? Because the radius is perpendicular to the tangent at the point of contact. So this angle is 90 degree. I should show it again. This angle is 90 degree as radius is perpendicular to the tangent at the point of contact. And using this, we can find this angle, right? We can find at least this angle in a right angle triangle by applying the trigonometric ratio. We can obtain this angle. Well, what we know from here that looking into this figure, it's a right angle triangle. We can find out that we know the hypotenuse, and we know the base. So we can apply cos, right? The relation. So let's say the triangle here, it is in triangle that is OTP, right? In triangle OTP, we know this angle, we know what we said, cos, right? So cos, let's say I take this angle as theta. So cos theta is equal to what? Base upon hypotenuse. Base is OT over hypotenuse is TP. So let's say this is cos theta only is equal to OT, as you can see from the figure, is R, and OP is 2 times R. This gets reduced and we get cos theta is equal to half. And cos is half when theta is 30 degree. Is it 30? No, 60 degree. It is theta is equal to 60 degree. Now check, we have found one angle here as 60 degree. Let me erase everything. We found this angle as 60 degree. This is 60 degree. Now, as you know that these two triangles are congruent, or you may prove in the these two triangles as congruent using SAS. Now let me tell you why these two triangles are congruent. Once again, I should properly show it, as you should do in the exam also. So what you know that in these two triangles, that is, I can write straight away triangle congruent, and I should tell you why. Number one, we have TP is equal to SP, that is tangent from same exterior point. This is common, that is OP is common, and here OT is equal to OS, that is radii of the same circle. So we can say that the triangles are congruent by SSS. So I'll write triangle OTP is congruent to triangle OSP, and the reason is by SSS congruency. Now, once these two triangles are congruent, right? Once you prove these two triangles congruent, then from CPCT you can write this angle as 60 degree. So 60 plus 60, that is 120 degree. Let me show you. This is 60, and therefore 60 plus 60 is 120 degree. So we got this angle. I can show you. We have angle TOS is equal to 60 plus 60, that is 120 degree. Now you consider this triangle, and we'll use isosceles triangle property. To end this sum, we'll be using isosceles property. So let's shift it a bit above. Okay, so here I'm considering the triangle, and the triangle is in triangle TOS. What we have OT is equal to OS, and the reason is radii of the same circle. So I can say this angle, say X, will be equal to this. So we can say here the angles, which is angle OTS is equal to angle OST, and I've taken this as X. And the reason is angles opposite to equal side, or you may simply write isosceles triangle property. So now you can say that in the same triangle, the sum of three angles is how much? 180 degree. So the sum of these three angles of this triangle is 180 degree. So this is X plus X is 2X. The value of TOS we calculated as 120 degree is equal to 180 degree. Finally, what you can say that X is, first of all, 2X, right? 2X is what? 2X is 180 minus 120, that is 60. And that implies X is equal to 60 divided by 2, that is 30 degree. So that's what we need to prove here, that these two angles are 60 degree. So we proved this as well as this angle as 30 degree. Right? 30 is what we needed to prove. I can say this is what. So we'll say hence proved.